Hi, this is Misconception, and I'm going to be doing a quick review on comparing fractions. Okay, so let's begin by first reviewing what these symbols mean. This one means greater than, this one means less than, and this one means equal to. And the way I like to remember it is I like to imagine these as like an open mouth, and it wants to eat whatever fraction is bigger. So if 4/5 was bigger, my mouth would want to open up towards the 4/5. Same thing with if the 4/6 was bigger, my mouth would want to open up to 4/6 and eat it. Okay? So, the very first step I always do when I'm comparing fractions is I look at my denominators to check if they are the same. In this case, they are different, so I'm going to want to make them the same because it's hard to compare two things that are very different. So, the way I like to do it, the strategy I usually use is finding multiples. So I'm going to start by finding multiples of 5. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25, and 5 times 6 is 30. I'm going to do the same thing with 6. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, and 6 times 6 is 36. Okay. When I see that I have a good amount of multiples, I look at both lists and I see which numbers they have the same. And I notice that 30 was a number that they both had. So that is now my lowest common denominator. Now, I want to change my 5 into a 30 because that's what this is telling me. It's telling me that I want to change my denominators into 30s. How am I going to change a 5 into a 30? Well, I know that 5 times 6 is 30, and everything I do to the bottom of my fraction I do to the top because I want to make it an equivalent fraction. So then now my fraction turns into 4 times 6, which is 24, and 5 times 6, which is 30. Now I'm going to do the same thing to the 4/6. I want to change my denominator into a 30. How am I going to do that? Well, I know that 6 times 5, 1, 2, 3, 4, 5, is 30. And everything I do to the bottom, again, I do to the top because I want to make it an equivalent fraction. So now my fraction turns into 4 times 5, which is 20. And then my denominator turns into 30. Now, my denominators are the same. My denominators are 30. And now all I need to compare are my numerators, 24 and 20. Which one is bigger? I know that 24 is bigger, so my mouth wants to open up and eat the 24. So I would want to circle that symbol because it is greater than. And if we go back to our original fractions, we know that 4/5 is greater than 4/6. Okay? There's another strategy you can do instead of finding multiples. I like to do it this way because I like to find the lowest common multiple. But you can also multiply the denominators with each other. So, for example, if I had the fraction 3/10, and I was trying to compare it to 4/11. Again, my first step is to look at my denominators and see if they're the same, and they're not. So what I can do is just multiply them by each other. So I would multiply 10 by 11, and then I would multiply 11 by 10. And then remember, everything I do to the bottom I do to the top because I want them to still stay equivalent. I still want equivalent fractions, right? So then now I have 3 times 11, which is 33. 10 times 11, which is 110. Okay, so my 3/10 now became 33 110ths. I did the same thing to the other side. So 4 times 10 is 40. And 11 times 10 is 110. My 4/11ths turned into a 40 110ths. Now my denominators are the same. So it's easy for me to compare these fractions. I just need to compare my numerators. So which one's bigger, 33 or 40? I know that 40 is bigger, so my symbol wants to go eat the 40, right? Remember, it wants to go eat the 40, the bigger one. So I know that 3/10 is less than 4/11. If I go back to my original fractions. So 3/10 is less than 4/11. Okay? So those are two strategies you can use to compare fractions. They both work. It just depends on what you prefer. Okay? So I hope this was helpful, and I will see you next time. Thanks. Bye.